Okay, this is part 2 of our 2000 Lexus RX 300. And again, this vehicle comes in and it doesn't start. It has all the symptoms of low compression. Long story short, in this case, we have an idle air control problem, so we're going to address the idle air control motor on this vehicle. First place we're starting is a wiring diagram, see what kind of idle air control motor we have. This is a 3-pin idle air control, as it shows right here. There's my idle control valve, top rear of the engine, 3-pin, and what we have is this white-black wire, goes right to a ground splice, so this is constantly grounded. I've already tracked this black with the red right here. That is a 12-volt feed from the EFI main relay. So we have a constant 12 volts on this wire, we have a constant ground on this wire, and if you look at this wiring diagram, that means that this coil right here is constantly energized. We have a constant magnetic field around this one coil in this design. The other coil, which is this one, this yellow-red wire, this one goes to the computer and it is a pulse width modulated ground on that yellow with a red wire. It's a pulse ground. So the way that this valve is going to work is we will strengthen and weaken this magnetic field. This one stays the same all the time, and what that's going to do, this type of valve has a butterfly inside of it, and it's going to rotate to the left or it's going to rotate to the right based on these two magnetic fields. This is the way this one's working. Not all Toyotas are designed like this. Some of them actually had, this one was also pulse width modulated, and so we would control this one and this one, but in this case it's not like that. But very, very similar in construction. Again, inside of it we're going to find this plate, and that plate, the way it's going to move either this way or this way, is going to open up that air passage, and it's going to be based on the strength and weakness of that magnetic field. So what we want to do when we do our checks with this, and this is really important that you understand a little bit of theory behind this, is we want to do our voltage checks. And of course you can't do voltage checks on something unless you know what the voltage should be. What do we want to see on this, on pin 2s? We want to see battery voltage. We want to see between 12 and 14 volts with the engine running. We're going to do this stuff with the engine running. So we want battery voltage on this black-red wire. And then on the white-black wire, not sure exactly what would be tolerable here, but a few hundred millivolts at most on this ground. Maybe 300 millivolts or less, I'd be happy with that. And the reason I'm giving you a little bit higher ground voltage, a little bit more current flow on this circuit, so I'm okay with that. Low voltage on the white-black, 14 volts battery voltage on the black-red, and then what we want to see on this yellow-red, some type of square wave pulse width on-off signal. I'm not sure exactly right now. I've never done one on this car. It might have some spikes to it. Those spikes would be when it's on, the voltage is low because it's ground side switched. When it's off, the voltage is going to be high. You're going to have voltage come through here, through the coil, and the voltage will be high coming out of this yellow-red wire unless the computer's grounding it. So maybe voltage low, and then you might get a spike afterward because of the design that it's ground side switched. So we might actually have a square wave with spikes on it, and that could be normal too. And those spikes would simply be the collapse of the magnetic field when it's turned off. So again, I don't know exactly what this one's going to look like. That's the test we're going to do. We need to confirm that the computer is able to control this valve before we pull the valve off and say that it's mechanically stuck, which is the common problem. So that's what we're going to do now. We're going to go to the scope and we're going to pull up. We can actually do all 3 channels at the same time. We have that luxury. Maybe we'll do it like that. Put it back up on the screen. Okay, go ahead, pause. Okay, I want to warn you guys of one thing. I said we're going to look at all 3 at the same time. This really is a safety concern with the engine computer doing this. I'm using insulated T-pins, and actually I got these. Where's that kit? Can I see that? These are from Pico. These are electronic acupuncture probes, and they're insulated. So when it's a T-pin basically, but they're insulated. The reason I'm using these, because we're going to do all 3 channels. And if I use 3 T-pins, and these things touch each other, remember that this is a battery positive, this is a ground. If these 2 touch each other, I'm going to blow the fuse. If these 2 touch each other, my battery positive and my ground side switch computer driver, I'm going to cook the computer. So we need to be extra careful about what we're doing with T-pins. I know that I stress to never double T-pin a solenoid, which is what we're about to do. I'm doing it because I want them all in one picture so I can show you how the thing operates. I'm not suggesting in the field that you do all 3 at the same time. Do them one at a time. You only need a single channel. Check your power, check your ground, check your control signal. Don't do them all at once. Okay, pause that for me. All right, the tool we're using for this test is the Picoscope 4000 series. And I'll give you a shot under the hood, show you where our connections are at the idle air control motor. Okay, I'm under the hood. Very difficult to get to this idle air control valve. It's underneath the throttle body. You see my leads are connected to that connector, 3-pin connector under the throttle body, 1 to each terminal. Again, I'm using insulated type T-pins. You don't want these touching each other. And we'll go back up to the computer screen and I'll explain to you what's going on with these 3 readings. Okay, again where we are. 3-pin idle air control, common power, common ground, or constant power, constant ground, pulsed ground. So my 3 connections, my green trace is my ground. See, I'm at 0 volts. My red trace is my battery positive. My power feed, it's at 0, the key is off right now. And my blue trace is my computer pulsed ground. It is also at 0. I have these set on a 20-volt scale for each. The time base will adjust accordingly, depends on what the picture looks like. Turn the key on for me. Alright, so you see initial key on. I do have a battery charger on this, so some of the up-down oscillations that we have in here, a little bit of interference from this battery charger. You see we have battery voltage, that's power from the EFI main relay. You see my ground is maintaining near 0 volts, and my computer controlled wire for this idle air control is near battery voltage, not quite. Okay, start the car. I'm going to need you to hold your foot on the gas pedal a little bit to keep it running. And truthfully, just by this waveform, we have everything that we need for this idle air control valve to be functioning. We have our pulse ground, as noted by this picture. And this in itself tells us that the computer is able to control this idle air control motor. Our constant battery voltage up here, which we showed on the diagram, is what it should look like. And our constant ground. Our ground looks good, our feed looks good, our pulse control looks good. This is all going to point to we have a stuck idle air control motor. Ideally, what should happen, this picture right here, let me pause this. Go ahead and let that stall. What should happen in this picture is the pulse width or the duty cycle is going to change. When the computer wants different idle speeds, what you will see is this on and this off time is going to change. This is my off time in this picture because our voltage is high. This is ground side switched. So my on section is down here. If the computer wants this magnetic field, that second coil, to be a stronger magnet, it would look something like this. It would be a shorter off time and a longer on time. If the computer wants this magnetic field to be weaker, what it's going to look like is the off time is going to increase, the on time is going to decrease. And so that's how it's controlling the magnetic field on that separate coil, with a variable on-off time. Weakens or strengthens the magnetic field. Now what we don't know on this is which way it should be. We don't know if the command is or this coil, this second coil, we don't know if this second coil needs to be stronger to close the idle air control, or it needs to be stronger to open it, and it really doesn't matter for what we're doing right now. Our focus is, can the computer control this valve? And the answer is yes. Is the valve functioning like it should be? The answer is no. This vehicle continues to stall. And no idle controls whatsoever. So our next step in this process, we're going to pull this motor, and I'm going to show you how to hopefully clean this thing, and if we can't clean it, we're going to have to replace it. All right, procedure tells us to take this throttle body off to get to it. And what we've done is, the electrical part we've already unbolted, and this is the electrical part to it. Where our focus is on the mechanical part, which is this piece in here. Now, unfortunately on this one, I can't pull it all the way off right now to show you what the butterfly valve looks like. This does have one, and what we're gonna try to do, instead of unbolting the whole throttle body, is we're gonna try to just work this valve back and forth and try to knock all the carbon deposits off of it. If you reach down and grab this thing, it's really, really tight. And actually I can turn it, but just not very easily. And so all I'm really gonna do is try to free this up, is just work it back and forth. And if we get this thing moving to very freely, then what we can do, there's an O-ring there, don't want to lose that O-ring. Move this thing back and forth. It gets us to the point where it takes very little pressure to turn it. We should be able to bolt this back up and be good to go. In fact, I'm pretty happy already with how free this is. You know, what happens with these is, this is a steel shaft and it's an aluminum housing, and the aluminum housing will oxidize. And what I'm doing basically right now is I'm just knocking all that oxidation off the inside of this aluminum housing. That's pretty free now. What you can do on these two, if they're real bad, you take these things all the way off. There is a cover on the back side that limits how far this will travel, and you can take that cover off, but you want to mark very closely where this shaft sits, because you don't want to put it on backwards. But you can take it off, and you can actually spin this thing in 360 degrees and really knock all the stuff off of it. But it's actually pretty good right now. I think this particular one is magnetic too. That is there's a permanent magnet. So we really have 3 magnets if you think about it on this. There's 2 electromagnets and there's 1 permanent magnet. The permanent magnet is on this shaft, like right where my finger is. Is that still in the shot? You still see what I'm doing? Okay. That's pretty clean now. I think we can put this thing back together. See what happens. So all I did was work it. We didn't use really any penetrating oil or anything like that. I'm just working it back and forth. That's pretty clean, pretty free. Let's bolt it back up, see what happens. All right, so we bolted this back together. That was obviously a lot easier than taking the throttle body off. We're pretty sure that this thing's gonna start now. Go ahead and try it. You see we were not on the throttle. Kind of zoom you in on the throttle here. Go ahead, snap the throttle once. Snap it. There you go. All right, you weren't even in the car, were you? Shut it back off. Start it back up again. We should hear a flare up. That is a fix. Shut it back off. I want to mention one more thing to you guys, and then we can show the waveform of the idle air control after. It's really not necessary. I don't know. Maybe I won't show it. One of the things that you want to listen for an idle control is, and I call this in my book, an IAC functional test, is when you start the car, every time you start the car, you should hear an idle flare up. And so what you want to do is listen closely. The RPM should rise a little bit, maybe 1300 RPM, and then fall back down to a normal idle speed. Every car is going to be different as far as how much it's going to rise, but listen for that flare up. Go ahead, start it. Shut it off. One more time, listen to it again. You saw both times we started this car, this had a flare up, you could hear it. and it's starting to fall back down, and that's telling you the idle air control motor is functional in both directions. Very valuable test. Stuck, closed idle air control valve. This is typical to any 3-wire Toyota, 3-wire Lexus idle air control where they're using those 2 magnetic fields with that butterfly type valve. Sorry I couldn't show you the inside of this one. Very, very common problem. Easy fix. Okay, I wanted to show the after the fix, what the waveform looks like, what it's supposed to do. I'm leaving the power and ground out of this. I'm just showing the 1 pulse ground, the 1 computer ground. That's our blue tray, same one we had before. This car is actually idling now. Scott, turn your headlights off, please. Shut the car off. And what we want to do is watch this waveform. We'll watch it during the flare-up. And pay attention to this, this duty cycle number. I threw this percentage up here. Unfortunately, this is measuring the high portion, not the low portion. So the on time is going to be opposite here. But bear with me. Go ahead, start the car. See this duty cycle number changing. We'll let this stabilize. We'll get a number. The other thing that's going to help for where we are right now is for us to set up the trigger. Actually, to zoom in first, look at our time base at a lower level. Now this is walking on the screen. Maybe we'll look at it right there, it'll be even more clear. We'll set a trigger up and that'll keep it on the screen for us. The only problem with being down this low, it's having a hard time calculating that duty cycle. I'm gonna have to leave it on that one. All right. Hold your RPM at like 2 grand for a minute. We'll warm this up. Kind of look at these numbers. All right, let it idle. Okay, the number we're looking at right here, guys, this 57%. This is 57% off up here, it's on down here. This particular scope is measuring the high portion in this channel. So 57% we are off. Remember, it's ground side switched. So do your math. What's our math? 43% we're on. So we have an on time right now. This engine's not fully warm yet. Was I off a little bit? Okay. 43% is our on time. No loads. No accessories on, and by the way, we never cleaned the throttle plates on this, which we really need to do still. Because if this had clean throttle plates, we would have never had this initial complaint of, or direction we went with crazy stuff with vacuum. Anyway, I like to see usually about 30% when it comes to idle air controls. That's pretty much a good ballpark. So right away, this one's hot, just to compensate for no loads. Watch what happens to the on time down here as you increase load. So go in gear, high beams, rear window defogger, headlights on, blower on high, and you're going to see this number start to increase. You see this number's dropping, and this number's going to increase. Down to 44% up top. That means our on time has increased if our off time has decreased. And this is how it actually works. And here's what we know now. A stronger magnetic field on this other coil, on the computer controlled coil, a stronger field means open more, is what we now know by looking at this. So we want to do one more thing. I know I'm killing this, but it is what it is. Turn all your accessories off. Let's get a baseline number. And where were we? We were about 43%. Is that where that number was with all the accessories on? Let's see where this sits with no accessories. We're going to clean this throttle plate. See if we can get this number to drop even more. That's better. We're about 40%. I'd like to see that a little bit lower. But this is how it should operate. This is an idle air controlled, pulse width modulated, or duty cycle controlled. Very, very similar to every other type of solenoid type idle air control valve. All right, pause that. Okay, throttle body. Looks clean on the front side, but where we care about it is right where the plates close. Can you open the throttle plates for me? And you see there is a black ring where these throttle plates close. It's very bad. Go ahead and close it again. Open it just a little bit. Right in there where that black ring is, we need to get rid of all that stuff. We're going to use a scrub brush and some carb clean. I'll show you the after picture. Okay, here's the after shot. Obviously, I'm not going to have carb clean next to my camera, so sorry we didn't show you that. Go ahead and open the throttle up slowly so we can see how clean the edges are. Good, keep opening. You see how nice and clean the edges are where that plate was closing? That's the stuff you have to get off. Spraying it's not enough, you got to scrub it. Want to look at our duty cycle percentage with this clean now, and I'll show you what it should look like. All right, this is after cleaning the throttle plate. Go ahead and start it. Okay, you might have to give a little bit of gas. We just got to flood it out from some carb clean. Hold your RPM up a little bit. Hold it at like 2 grams for a second. We'll blow all that stuff out. Okay, let it idle. All right, the number we want to look at is this number right here. So we're at 55%. Still let this stabilize a little bit. That's not too much different from where we were, is it?
That's about the same.
We were about 40%. I wanted to be around 30% down here. Hold your RPM back up. Get this warmed up. Okay, let it idle. $61. Where were we before? 55. Still like to see this number around 30%. I'm not sure how much improvement we got on that. Let's put all the accessory loads on now and look at it like that. High beams, rear window defogger, blower on high, AC on. We in gear too? Were we in gear before when we did the shot before? Put it back in gear. You guys remember what our number was here? 43. So we had about a 7% improvement roughly. And this all has to do with the air going past the throttle plate. Something for you guys to read. This wasn't a major improvement with the throttle body clean, but section 21, you guys have my book. Section 21, page 12, addresses what I'm talking about right now, which is giving this idle air control full control that it needs to have, and that has to do with the clean throttle plate. Turn all the accessories off. Let's let it idle one more time. Get one last number over here. So we're about 50% roughly with all the accessories on. That was the on time down here. Remember, this number is going to be opposite than what we're looking at. So all the accessories off, we're sitting around 39, 38% roughly. I like that better than where we were before. That was definitely an improvement. Of course, the overall problem with this car was a sticking idle air control valve.